And if anyone has anything specific that they do want to go through, right? Like any specific questions, let me know now, because I'm going to put some options up on the board. Okay. So option number 1 is logs, logarithms. 2, the other thing that that I could go through is anti-differentiation and primitive functions. And by primitive functions, I don't mean bodily functions. Number 3, what we can go through is, let's have a look. We could probably also go through probability. Okay, now is any of these, Reef, on your list of things that are going to be tested on tomorrow?
Yeah, I'm just checking now.
Okay. And then the other things was permutations and combinations. Yep. Niall, do you have a specific preference?
No, I don't really mind. I don't know any of them, so.
Okay.
Any. We're doing probability right now, though.
Okay, cool. Is there? Do you have any questions specifically on probability?
No, not at the moment. I asked you all the ones that I had yesterday.
Yes, and did you have a look at the Monty Hall problem video?
Yeah.
Did it make sense?
Yeah.
Yeah.
I think perms and comms are the only ones in the test tomorrow.
Oh, okay. Yep. Anthony and Niall, have you done perms and comms?
No.
Anthony, have you done perms and comms?
No.
Okay. Perms and comms, I will say, is part of probability, right? So it's kind of, these two kind of go together. And Niall, I was going to say, we actually did do perms and comms.
Oh, we did?
Yeah, in disguise.
Okay.
So I was going to suggest we might even start off by doing a little bit of permutations and combinations. Okay, right? So I'll just kind of start from the ground up with permutations and combinations then. You guys okay with that?
Yeah.
Yep.
You will find that you'll pick this up fairly quickly. Okay, so the first one is called the multiplication principle. Right, I'm going to build this up from the ground up. The first thing we're going to do is we're going to go through what we call the multiplication principle. Okay. Okay, so the multiplication principle says you multiply when you're trying to work out the number of arrangements of something. Okay, so I'll give you an example. I have 5 shirts and I have 4 pairs of pants. Okay, I also have 7 pairs of socks. How many ways can I arrange an outfit? Okay. Any ideas?
You add up the total and then you get it depends, is every shirt and pants and like socks, like are they all different?
Yeah, they're all different.
Then you do 5 plus 4 plus 7 and then you get the factorial of whatever that is, and that's the total number of ways that you can arrange them.
Where's your logic in that? Explain to me your logic.
That's what we did yesterday.
But think about it. All right. So
if you have 3, then
here, how many pants can you choose?
Yeah, you can choose 4.
4 pairs of pants, right? Now, of these 4 pairs of pants, each pair of pants can be matched with one of 5 shirts. Does that make sense? So how many ways can you arrange 4 pairs of pants and 5 shirts to make an outfit for yourself?
Would it be 5 times 4 times 3? Oh, wait, times 7?
Yes. So it'd be 5 So 4 times 5 times 7. Is everyone okay with that?
Yeah.
Yep. Niall, are you okay with that?
Yeah.
Yeah. Why is that? Because this is what we call the multiplication principle, okay? Which is basically 140 in this case.
Mm-hmm.
Yep. Okay, so that's called the multiplication principle, okay? Now, when you extend the multiplication principle to factorials, right? Okay, then it looks something like this, right? You have 5 letters, right? And you have 5 envelopes. Okay? How many ways can you put 5 letters in 5 envelopes?
25.
Sorry?
25.
Not 25, no.
5 factorial, which is
How many letters can you put in? So this is envelope 1. This is envelope 2. Envelope 3. Envelope 4.
120.
Yep. And envelope 5. Okay. Now, how many letters can possibly go into the first envelope?
How many letters? 5.
5, right? Once you've chosen the letter to go into the first envelope, how many?
Oh, it's 5 times 4 times 3 times 2 times 1.
Yes.
Okay.
Reef, you're
Yep.
okay with this? Yep. 5 times,
Yep.
4 times 3 times 2 times 1, right? That is what we call 5 factorial. Okay. Factorial just means you multiply every single number, every single whole number, starting with the number that's in front of the factorial, descending by 1 until you get to 1. Okay. 5 times 4 times 3 times 2 times 1. Does that make sense?
Yeah.
Okay. Okay. So I'll give you another example, right? How many ways can you line up 16 boys in a line? Yep. How many ways can you line up 16 boys in a line?
Is it 16 factorial?
Yes, the answer would be 16 factorial. Got it? Because you have 16 possible boys or 16 possible choices in the first position, right? Once you've chosen that person to go in the first position, then you've got 15 left over that can go into the next position, 14, 13, 12, ... Okay, and we use the multiplication principle, right, to work out how many arrangements they are. Okay, so the number at the end is 16 factorial, right? And that represents the number of arrangements. Now, I'm going to focus on this word very, very carefully. Arrangements, okay? Arrangements. So when you've got an arrangement, it's the number of choices where, or the number of ways that you can arrange things so that order is going to matter, okay? Order has to matter, okay? Is everyone okay with that?
Yeah.
Yeah.
Very important. Order matters, okay? Now, there is another word for arrangement. There is another word that's mathematical, and it's the same word for arrangement, and that is the word permutation, okay? The number of we can call an arrangement a permutation, right? How many permutations are there? Well, that's the same as the number of arrangements there are. Got it?
Mm-hmm.
Yep.
Okay. And what's special about a permutation?
The order matters.
The order matters. Okay. Now just keep that into the back of your mind. Okay. Now, here's the other thing. This time, we're going to line up 16 boys in a line of 11, right, for a soccer team. Okay. So this is for a soccer team. What would that look like? So you'd have 11 spaces, yeah?
Yeah.
What number would go into the first space? How many boys can you put into the first position?
16.
16.
16. In the second position?
15.
15.
What is it? 16 factorial times 11 factorial?
No.
Oh.
I like how you're thinking. 11, 10. Now, in the last position, right? That's what's that? The 11th position? Yep.
Mm-hmm.
How many can you put into the 11th position?
5.
Okay. Yep. 5. Does
Yeah.
that make sense?
Yes.
Okay. How would you express that as a factorial? Have a think. Reef, do you know the answer?
Would it be wait 1 second. Would it be 16 factorial minus 5 factorial?
Close. Close. You're on the right track. Anyone else want to have a guess? I'll tell you. I'll give you a hint. 16 times 15 times ... 5 times 4 times 3 times 2 times 1. Okay?
I'll divide 5. Okay, factorial.
Yes, right? So we just want this bit. Got it? Okay?
Yeah.
And then this bit here, the 4 times 3 times 2 times 1, on that to cancel with that. So that all we're left with is just that, right? Yep.
Yeah.
What is
Yeah.
the top? The top is 16 factorial. Yep. Because 16 times all the way to 1. And what's
Yeah.
the bottom?
4 factorial.
4 factorial. And by the time you cancel the 4 factorial out of the 16 factorial, you're actually left with the answer. Does that make sense?
Yeah.
Mm.
Yes. So that is what we call 16 choose. What's that called? 16 choose 11. Okay. 16p11. Right. Now 16p11 is 16 factorial over 16 minus 11 factorial. Now, can I just say, I think I stuffed up. Can anyone see where I stuffed up before I tell you? If you're bright and you're paying attention, you might actually see my mistake.
Well, you said 16 minus 11 and it says 4.
Yeah.
Yeah.
Okay. So this position here, that position there should be 6 left over, not 11.
Yeah.
Okay. Which means that you need a times 5 here. That's a 5 factorial.
Why is there 6 left over?
There isn't.
So why you wrote a
okay,
6?
okay, cool. Yeah, so it's 5 factorial. Okay, so if we were to count 11 positions, right? So this is 1, 2. This is the first position, second position, third position. When we get to the 11th position, what number would we put in here? Well, let's have a think. What's 16 plus 1?
17.
What's 15 plus 2?
17.
What's
So it'd be
it would be
11th and then
6.
okay.
Yep. So what we want to see cancel are the first 5 numbers and the first 5 numbers. Does that make sense?
Yeah.
Okay, cool. So when you've got 11 people that you're choosing from 16 choices, right? We write that as 16 P11, okay? And that is essentially 16 factorial over 16 minus 11 factorial, which is how we get 16 on 5 factorial. Does that make sense?
Yeah.
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 Okay, so what do you think the P stands for?
Permutation? No.
And what's special about a permutation?
It has order.
Order. Order matters. Got it? Order matters. Okay, now let me show you my calculator. Can you see my calculator?
Uh-huh.
Yeah.
Okay, let me do that. All right, so I'm going to turn my calculator on. Yep. Do you see this little button here? NPR.
Yes.
All your calculators should have it. NPR.
Yep.
Okay. Now that is the way we write that. Okay. So we go 16 shift times 11. Got it?
Yeah.
And that will give us the answer. Okay. So what do we got? 1.743565824 times 10 to the power of 11. Got it?
Yeah.
Now, let's see if that's exactly what we get. So another way of doing this is 16 factorial.
Factorial.
Now, where's the factorial button? Can you guys see it?
Yeah.
Yeah.
Where is it?
It's like in the top right below the on button. It's different for us on our calculators.
Yeah.
Oh, okay.
It's top right. On the
Yeah, here we go. Okay, so 16 factorial over 5 factorial. And do we get the same answer? Yes, we get the same.
Yeah.
And another way we can do it is 16 times 15 times 14 times 13 times 12 times 11 times 10 times 9 times 8 times 7 times 6. Got it?
Yeah.
What? Why am I out? Times 5. Hang on.
You missed a 1 in 11.
Oh, did I miss a 1 in 11? So let's times it by 11.
So
Yep. Do you see?
Mm-hmm.
Everyone understand?
Yeah.
Yeah.
Right. So that's the principle behind permutations. Got it?
Yeah.
Okay.
Mhm.
So here's what I want you to do, right? In the word, amazing. Amazing. How many 3-letter words can you choose or can you create in the word, from the word amazing, right? Where you can use where you use every letter can only be used once.
1, 2, 3, 4, 5, 6.
Yeah, 1, 2, 3, 4, 5, 6, 7. So you got 7,
6.
right? But you can only use the A once. So you're choosing from 6, right? And we're selecting 3.
So is that 120?
So what would you put in your calculator in P?
You do 6 and then P and then 120.
No.
No, sorry. 6 and then P and then 3.
Yes. Now, how would you write that in factorial notation?
You do 6 factorial over 3 factorial.
Yeah, 6 minus 3 in brackets.
Or
Okay.
just 3 factorial.
Yeah, I wouldn't use 3. I'd use 6 minus 3. Now,
Okay.
the reason why I'd use 6 minus 3 is because you don't want to leave the marker confused as to whether you're not using this 3, right? Or 3,
Yeah.
the difference of 6 and 3. Got it?
Okay.
Yep. And it's just a way that you're telling the marker where you're getting that 3 from, okay? Even though it'll give you the same result, okay? And then the last way to express it is 6 times 5 times 4, okay?
Yeah.
Does that make sense? And
Would having 2 A's make a difference?
sorry?
Would having 2 A's make a difference?
Yes, because I'm going to show you a slightly more advanced question, right? I'm going to show you a slightly more advanced question. Okay, afterwards. Okay. Now, does that make sense, guys?
Yeah.
Okay. Now, a slightly more advanced question is, how many ways can you create a 7-letter word from amazing by how many permutations are there of the word amazing by rearranging the letters? 1, 2, 3, 4, 5, 6, and then 7 letters, right? Because 1, 2, 3, 4, 5, 6, 7. Got it? Yep.
Can you still only use each letter like once in the thing?
Yes. Well, no, you've got to use each individual letter.
But can you use like
7 letters
2
once.
A's now?
Sorry?
Can you use 2 like?
You'll have to use 2 A's.
Okay.
Because there's 7 letters, right? So how many different ways would there be of arranging
5,040.
the word amazing, right? Now I'm not interested in the value. I'm interested in the expression.
So 7 factorial
Then what?
on 7 minus 7. Oh wait, hang on.
Would it be 7 factorial divide 2?
Close. And
Okay.
is yes.
Oh, 2 factorial.
2 factorial. Good.
Okay.
Okay. Now, does that make sense to everyone?
Yes.
Because let me explain, because I get the feeling that you might need an explanation for this, right? Now, notice that the 2 A's are what? They're identical, right? The 2 A's are identical, right? Now, if each of the letters were different from one another, then you have 7 factorial ways of...
Yeah.
Yep, right? And that is if you had A1 and A2 each other, right?
Yeah.
But they're not, right? So for every time you've got an A1, for every time you've got an A and an A and an A sitting in this arrangement, right? You've got half as many ways of actually arranging them because A1 and A2 are interchangeable. Does that make sense?
Yeah.
Okay, so you've actually got to halve the number of arrangements from 7 factorial. Does that make sense?
Yep.
So
You've
what
got
if
to
there's
divide
3
by
A's
2.
that would be on, you'd divide it by 3.
Would you divide it by 3 or would you divide it by some other number?
Well, you said you have to half it if there's 2. So
Yes. Now, why do you have to halve it? Because 2 factorial is
2.
2.
2.
So if it's
right?
3, it'll be divided by what, 6 or something?
Possibly. Well, let's investigate. So imagine if you had A3, right? So A3 here, right? Could you have a situation where you've got A1, A3, and would that be identical if all the other letters were identical? That's not a rhetorical question. That's a
Can
question.
you say the question again?
Okay, so like if you had an arrangement where these letters were all equal or all the same, right?
Yep.
But the only difference was that the A's were rearranged. So A1, A2, A3. And in this situation,
Are they labeled as A1, A2, or A3, or are they just 3 A's?
well, if they were all identical A's,
Yeah.
right, indistinguishable and identical,
Mhm.
right?
Yeah.
Yeah.
Would this be the same arrangement?
Yeah. Yes.
Yes, right? So this arrangement is exactly the same as this arrangement.
Yes.
So we're counting
many-
all the A's as the same, but
That's
why
what I
is there
said.
like different numbers next to them then?
What I'm trying to illustrate is how many duplicates of
Oh, okay. So, okay. So it doesn't affect like it doesn't make
how many duplicates will there be?
3 factorial, which is
There'll be
6.
3 factorial because you can have a situation where it's A1, A2, A3, A1, A3, A2,
Yeah.
2, A1, A3, A2, A3, A1. Yep. Do you see what I'm saying? You can have A3, A1, A2, A3, A2, A1. So how many duplicates of this arrangement are there? 6.
6.
3 factorial.
1, 2, 3, 4,
Yeah, 3 factorial.
5, 6. Yeah. So to eliminate all those duplicates, because these A's are all identical, we'd have to take 7 factorial and divide it by
3 factorial.
3 factorial. Does that make sense?
Yeah.
Yes.
Kyle, you're okay with that?
Yep.
Yep. So when you have repeated letters, right, you actually have to divide your total number of permutations by the number of duplicates. Does that make sense? Right. Okay. Let's take another word. What about the word amazing? Let's say hang on, I'll spell it differently. As in this time we're going to spell it amazing, as in corn. Right? Right. So that's maize as in corn, right? How many different permutations are there of the letters in the word amazing if each letter is used once and only once?
Is it 7 factorial over?
Well,
2
there's 8 letters this
factorial?
time.
Yeah.
1, 2, 3,
Factorial.
4, 5, 6, 7, 8.
You have to divide it by 2 factorial twice. So
Yes.
Yeah.
Got it? So it's
Yeah.
8 factorial over 2 factorial, 2 factorial, right?
Yeah.
This 2 factorial because of the double A's, right? This 2 factorial because of the double I's. Got it?
Yes.
Yep. Okay. Is everyone cool with that?
Yeah.
Mhm.
Another type of permutation that's quite common is circles. Instead of arranging things in a line, we're going to arrange things in a circle, right? So 1, 2, 3, 4, 5, 6, 7. Okay. So how many ways can you arrange 7 boys
7 factorial.
around a circle?
Would that be 6 factorial?
Yes, it'll be 6 factorial. But before we say 6 factorial, there is a more precise way of expressing it. Okay.
Okay.
The answer will be the same. There's a more precise way of expressing
7 factorial divided by 7.
Yes, that's right. So 7 factorial divided by 7. Does anyone know why?
Oh, that makes sense.
Why? Well, if it makes sense, Anthony, can you explain it?
Yeah, well, is there 7 different boys? Is there a chance you'll have some combinations that will overlap, or is that why? You have a
Yes.
seven at the bottom.
Yes.
You'll have combinations overlapping, so you have to eliminate those combinations.
Yeah, not quite.
Okay.
Yeah, well, yeah, you're right. It is right, but not quite precise. Okay.
Yeah. Okay.
Price, not quite the full picture. You're on the right track, but you haven't gone far enough. All right.
Okay.
Let me explain. Okay. If you've got 1, 2, 3, 4, 5, 6, 7, right? A, B, C, D, E, F, G, right? That's one combination. Or what? Sorry, hang on. That's one permutation. Got it?
Yeah.
And that's if it's in a straight line. Okay. But if it's in a circle, right? Where's the start of the circle?
Oh, there is no start of the circle.
There's no start of the circle, right? So let me give you another situation, or another arrangement.
Yeah, it can go E, F, G, A, B, C, D if it's in a line, but yeah.
Okay, so if it's in a circle, right? Is this arrangement the same as this arrangement?
Yes.
Yes.
Yeah.
And how many duplicates of this arrangement are there?
7.
7. Does that make sense?
Yes.
It's in a circle, right? If it's in a circle, you take the number of arrangements in a straight line and divide by 7. Got it?
Yeah.
Cool. Let me give you another example. Imagine this time you've got a straight line. 1, 2, 3, 4, 5, 6, 7. And this time you have 4 boys and 3 girls. How many ways can you arrange 4 boys and 3 girls in such a way that the boys are together and the girls are together?
Oh, would it be 4 factorial times 3 factorial?
What do other people think?
Do you have to use the P symbol or?
Yep, you can use the P symbol.
Okay.
Yep.
So would that be 4P3 or?
No.
Okay.
Reef, you're very, very close. Niall?
Would it be 4 factorial times 3 factorial divided by, I'm not really sure. It'll be divided by something probably.
No. Okay, so Reef, tell me why you chose 4 factorial times 3 factorial.
Well, it's basically 2 groups, and then there's
Yep.
different arrangements in the groups.
Okay.
Like,
So the boys have to be together. Let me just go. Yep. So the boys have to be together. So these 4 boys, right? And that's 4 factorial. Yep. And these 3 girls have to be together. Is that right? And that's 3 factorial. So So the number of arrangements for the boys is 4 factorial. The number of arrangements for the girls is 3 factorial. And we use the multiplication principle, right? So we get 4 factorial times 3 factorial. Is that right?
Yeah.
Yes. What have we? That's like 90% of the way there. What's the other 10%? Any ideas? I'll tell you, and you tell me why.
Oh, because it can be like girl, boy, or
Oh,
boy,
yeah.
girl, like the
Yep.
groups.
Yep. So you can have the arrangements being girls first, or you can have the arrangements being boys first. Does that make sense?
Yes.
Yeah. Okay. You ready for the next type of question?
Yep.
All right. This time we're asking the same question. 1, 2, 3, 4, 5, 6, 7. Oh, 7, right? Okay. And you have 4 boys and 3 girls. And how many ways can we arrange 4 boys and 3 girls so that they're sitting alternately? They're alternating, right?
Oh.
Is it?
Yeah, someone choose. You tell me.
There's 7. Is it 4 factorial times 3 factorial times 7 factorial? No, divided by 2? Actually, that doesn't make sense. Never mind.
Have a think. Do you like perms and comms?
Yeah.
Like permutations?
So
People hate it. Some people, you either love it or you hate it.
for the one before,
Yes.
swap them around. That's times 2.
Yeah.
So how many? 2. I don't know. It's 4. It's 4 factorial times 3 factorial. I think times. I'm not sure by what though, because I was going to say 7 factorial, but that wouldn't make any sense because it's alternating, not just in random order.
Yep. Niall, any thoughts, any ideas?
I'm not really sure.
Reef, any ideas?
Is it? Is it like divide 2 times something factorial?
No.
Okay.
Yeah. Good guess. Good attempt. Right. I like that you guys are thinking. Right. Now, if you start with a boy,
The next one will have to be a girl.
Isn't
girl,
it just 2?
boy,
Girl, boy, girl.
boy, girl, boy. Right. Now, can you start with a girl?
No.
Why not?
Yes. No. Oh, you can't.
Why can't you?
Because it'll be boy, boy at the
Because
end.
then there'll be a boy at the
Yeah.
end.
Yeah, that's right. So you can only start with a
boy.
Boy.
It's just because we got
Ah.
yeah. All right. So here we go. So can you see what I'm doing?
Yes.
Okay, so that's one set of arrangements. Okay?
Yeah.
Girls, another set of arrangements. Okay? Now, you've got how many ways can we arrange these 3 girls in those 3 positions?
3
factorial.
3 factorial. How many ways can we arrange these boys?
4 factorial.
4 factorial. So what's the answer?
4 factorial times 3.
Factorial. Got it?
Yeah.
Yep.
Is that the final answer?
Well, what do you think? Are you guys satisfied with that being the final answer?
I feel like there's more to it. Oh
is it
no.
because it's two? Is it?
Oh no, because it can only be boys
divided
first.
by two?
Yeah, that makes sense.
Yeah. Okay.
Yeah.
Okay.
This time we're going to add another girl. So there's 4 boys and 4 girls. And we're going to put them in the same arrangement, right? They have to alternate. It has to be alternating.
So wouldn't it just be 4 factorial times 4 factorial times 2? Or would you have more like combinations that you can do?
What do people think?
I get where he's coming from. I'm just actually
Okay.
Yeah, I
that
think it'll
makes
be
sense. Yeah, I agree. I agree.
factorial times 2.
Why is it 4 factorial times 4 factorial times 2? Before I give you the,
Because
right or wrong,
there's
I
4
want you guys
different
to
ways
commit
that the
to an
boys
answer.
can be
I agree with it.
arranged.
Yeah.
And then there's 4 different ways that the girls can be arranged. And then the boys can start first. And then the
Or the
girls
girls
can
can
also
start
start first.
Yeah, very good. Very good. So the answer is
4 factorial times 4
4
factorial.
factorial times 4
Yeah,
factorial times 2.
exactly.
Got it?
Yeah.
Yeah.
Awesome. Awesome. Now I'm going to make it slightly more interesting, right? This time we're going to arrange them into a line of 1, 2, 3, 4, 5, 6, 7. Right? It's a line of 7, and you got 4 boys and you got 4 girls.
Ooh.
And how many ways can
Is
you?
it still in the same alternating pattern
Yes,
as
it has
before?
to be an alternating pattern.
Jeez.
Is it? It's what we were doing earlier, where you had to minus.
Is it 4 factorial times 4p3?
Hang on, let me just. So say it again. 4 factorial times 4p3. Talk me through your logic.
Well, it's 4 factorial, and then I was thinking, yeah, because only 4 people can go into the 3, like the 3 spots, so that makes it 4p3, and then it's times 2, but because there can only be one order, it would be divide 2, which makes it just that. Do you know what I'm saying?
Can't it still though? It can still start with. It can start with boys and have 1 girl be left out, but it can also start with girls and have 1 boy be left out.
Yes. So.
Oh.
So, you're so close. So, ...
Times 2, or
Oh yeah, someone said it.
times 2.
Times 2.
Oh, really?
Yeah.
Oh.
Got it?
Oh.
Why is it times 2?
Because you can have 4 boys and 3 girls, or you can have 4 girls and 3 boys.
Oh, okay.
Does that make sense?
Yeah.
Yep. So that's why you times 2, because you can have 1 girl left out, or you can have 1 boy left out.
Yeah.
But regardless of which gender gets left out, you'll have 4 factorial arrangements for the gender that isn't left out, and you'll have 4p3 factorial arrangements of the number of where the gender is left out. Does that make sense?
Yeah.
Cool. All right.
So what was 4p3 like the same as? Was it 4 factorial on 3 factorial, or was it
Yes.
4 factorial on something else?
So 4 factorial on, well, in this case, 1 factorial.
What?
It's 4 factorial
Yeah.
on 4 minus 3 factorial.
Yeah. Okay.
Got it?
Yeah.
You guys ready for the next one?
Yeah.
Yep.
Yeah.
All right. How many ways can you arrange? Now that's 7, right? 4 boys and 3 girls, right? Around a circle. This is actually a really hard one. They're alternating, so that they're alternating. Oh, the answer is you can't. All right, so
Yeah. I was really confused there.
yeah, you can't.
Okay.
The answer is you can't because you'll end up with 2 boys. So see how you got a boy at the start and a boy at the end
Yeah.
when you've got 4 and 3, right? When you join that up into a circle, the 2 boys have to be together, right? So I want to change the question slightly. 4 boys around a circle. And they have to be alternating.
Would it be 4 factorial times 4 factorial divided by 8?
Not quite.
Okay.
So I love that attempt. That attempt's awesome. It's an awesome attempt. I like where you're coming from.
Or would it be times 2? Wait a minute.
Mm.
Wait. No, never mind.
Yeah, I'll tell you. It's 4 factorial over 4 factorial over 4. Over 4.
Oh, so you just times by 2.
Yeah. Okay.
Okay.
Duplicates, because see how you've got here duplicates are every one. You've got 7 line arrangements, right? That are going to be duplicated 7 times, right?
Yeah.
When you're alternating, those duplicates will only happen every alternate person. Is that
Okay.
Yeah. So it's 4 factorial over 4 factorial, right? Over 4, not over 8. Got it?
Yeah.
Yeah.
Yeah. Okay. You ready?
Mm-hmm.
Because we're going to move on to the next thing now, which is what we call a combination. Combination. Now, a combination is a selection. A selection, right? A permutation. Do you remember what permutation was?
With
Arrangement.
order.
Yeah, was an arrangement. What's the difference?
One of them order matters, the other in combination it doesn't matter.
Yeah. Ordered, non-ordered.
Wait, what? I thought in permutation order mattered.
Sorry, the other way around. I've got it the
Yeah.
other way around. Okay, cool. Hold on. Ordered, non-ordered. Got it?
Yeah.
I'll give you an example, okay? From a group of 30 students, a student representative council of 5 students was selected. Okay. Now, does the order matter? In other words, for a student representative council, right? All that matters is whether you're in the student representative council or not in. Okay. So does the order matter?
No.
No. Okay. So how many different ways are there of choosing 5 people from 30 people? Right. It's not like one person is the captain, the other person's the vice captain, the next person is the deputy, the treasurer. Like, it's not like everyone's got a unique position. It's just a representative council, right? 5 people on the committee. Got it?
Yeah.
How would we do that?
So what was the question again?
How many ways can you choose 5 students to represent a class of 30? So in this situation, are we dealing with a combination or a permutation?
Combination.
Combination, because does order matter or not matter?
Doesn't matter.
No, so order doesn't matter. Okay, so here we're dealing with a combination. Okay, and another way of looking at it is it's called a selection. Okay, a selection, right? You're selecting 5 from a group of 30, but you're not worried about arranging them in any particular order. Okay, any ideas how to do this? So in other words, A, B, C, D, E, right? That's one selection.
Yeah.
Yep. So A, B, C, D, E is the same selection as E, D, C, B, A. They're the same selection, right? Because if you were to put them if you put each of these, say, marbles in a bag, right? The order wouldn't matter, right?
Yeah.
B, C, A, D, E that's all still the same selection. Does that make sense?
Yeah.
Yeah.
So how many ways can you select 5 students from 30? So how many combinations would there be? Any ideas? Let me share with you some insight. How many arrangements would there be? Okay.
5.
So how many ways would you choose the first person? Or how many options would you have for choosing?
5.
No. You're choosing from a group of?
Oh, 30, sorry.
So 30 times?
Oh, 30 times 29 times 28 times 27 times 26.
26. Got it?
Yeah.
What's that? What's a way of expressing that?
What's it called? 30 factorial over 25 factorial.
Or
30p 25.
30p 5.
Or 5, sorry, yeah.
Yep. Does that make sense? Oh,
Yep.
And you don't need a factorial sign there. Sorry. Got it?
Yeah.
The number of
First choices.
arrangements.
Yeah.
Got it?
Oh,
But
yeah, sorry, overall choices, not first choice. Yeah.
right? But each arrangement is duplicated how many times? So each selection has how many duplicate arrangements?
Five.
Have a think. So if you've chosen each of the 5 members of this committee, right? How many arrangements are there of those 5 members?
Oh, 30p5 for each.
Ignore this for the time being. Let's just
Oh.
focus on these 5.
Would it be 25?
Nope.
Oh.
How many arrangements of these 5 people are there? Come on, you should.
5 factorial.
Yes, 5 factorial. Do you see that?
Yeah.
5, 4, 3.
I was just thrown
2,
off
1.
because we've just done the other thing. So.
Yeah. So 5 factorial, right?
Yeah.
In order to get the number of combinations of 5 students from 30, will there be more or less than the number of arrangements?
Less.
Yeah. So there's less selections than arrangements. Is that what you're saying?
Yes.
How much less?
Is it 30p5 minus 5 factorial times 5?
No, I like how you're thinking. 30p fact. So that's a good starting point. Yep. And so 30p5 factorial is the number of arrangements. What do we have to do with the number of arrangements to get the number of selections? Because each of these arrangements is duplicated.
Oh, do you divide by 5
Factorial.
factorial?
Yes, you divide by
5 factorial.
5 factorial. Does that make sense?
Yeah.
Right? Another way of writing this is 30 factorial over, right? Now, 30p5 is 30 factorial over 25 factorial.
Yeah.
So 25 factorial, 5 factorial.
5 factorial. Got it?
Yeah.
So these two numbers add up to this number. Does that make sense?
Yes.
Yeah.
Okay, cool. And so another way of writing it is 30C5.
What does C mean? Is that
C stands for, well, what does P
Oh,
stand
combination, yeah,
for?
combination.
Yeah. Now, do you see that on your calculator? You see that on your calculator? Where is it? There it is. You see it? Where is it? There it is. Yep.
Oh yeah, I see the NCR.
Yep. Okay. So what we do is we go 30C.
Jesus, that's a lot. Okay.
5. Got it?
Yep.
That. What do you get as an answer?
Yep.
What do you get?
That I got the same thing.
What do you get?
42,506.
506. Got it? Okay. And here's what I want you to try. Whoops. Here's what I want you to try. I want you to try the same thing. So what is it? 30p. Whoops. P.
Yep.
5. Right?
Mm-hmm.
Over. Well, whoops. That's not how you do it. You go 30p5 over 5. Is that right? Oh, 5 factorial. 5 factorial. Where is it? There it is.
Yeah, I guess the same answer.
Yep, and it gives you the same answer. Got it. Cool. Now, here's what I want you to tell me. What do you think 30C25 would equal to? So 30C5 is over here. What do you think 30C25 would equal?
Is it 30p25 on 25 factorial?
Yep. Yep. Do you want to work it out?
It's the same thing
Yeah. Why would it be the same thing?
because p25 divided by 25 factorial is, wait,
Okay.
let me
I'll
just
give you-
test.
I'll give you a hint. Have a look here. This is where you want to look.
Oh, okay. Because
30C5 is 25 here and 5 there. 30C25 B, 5 here and 25 here, right? Same thing, right? Now, have a think about it as well. Is there another way that you can explain why 30C5 is also going to be equal to 30C25? Okay, let me explain, right? Simply because we've gotten a little bit over time, I'm just going to rush this, well, not rush this, but explain this quite quickly, and the penny will drop, okay? Trust me, you'll go, oh, of course it is, right? All right, so when we choose 5 students, right, how many are left over?
oh yeah, okay. 25, yeah.
Yep. So by choosing 5 students to include, that's the same as choosing 25 students to exclude,
Yeah.
right?
Okay.
So the number of ways that you can select 5 students is going to be the same as 25 ways of excluding, sorry, the number of ways of excluding 25 students. Does that make sense?
Yes.
Yeah. So, so basically what I'm saying, I guess the point is, right, that selecting a certain number of students is always going to be the same as excluding whatever's complementary to that. Got it?
Mm-hmm.
Yeah. So let me end by saying this. NPR is equal to n factorial over n minus r factorial. NCR is equal to n factorial over n minus r factorial. R factorial. Got it?
Yes.
Which is also equal to n c n minus r. Got it?
Okay.
Okay.
Do we have any homework from this lesson?
Yeah. So if these two add up, if these two numbers add up to this number, right, then the C's are going to be equal, right? They're symmetrical. These two answers are going to be the same as each other. They're symmetrical to each other. Got it?
Yeah.
Okay.